Hello everybody. In this video, I will talk to you about a probability diagram, which I have adapted this question from a math question. Okay, let's read the question first. A scientist has two isotopes, bromine 79 and bromine 81, in equal abundance in a bag. Scientist wants to make Br2 1 plus ion from these isotopes. Scientist picks up an isotope at random, replaces it, and then picks again at random. Draw a probability diagram to represent this situation and use it to calculate the probability of making Br2 1 plus ion. Okay, we are going to make Br2 1 plus ion from these isotopes. Okay, I am just randomly picking up from the bag, which contains two isotopes. First pick can give me bromine 79, which has a probability of 1 out of 2. And then I may pick bromine 81. In my first pick, I can pick up bromine 79, which has a probability of 1 out of 2, or I can pick up bromine 81. This has also a probability of 1 out of 2. To make bromine 2 1 plus ion, I have to do a second pick. Okay, in my second pick, I may get a bromine 79. Again, the same chance, 1 out of 2 probability. Or I may get bromine 81. If I get bromine 79, then I will make this molecular ion. My first pick, my second pick, both has the same isotope, bromine 79, which gives me a mass to charge ratio of 182. Or I may get bromine 81. In my first pick, I got 79, bromine 79. In my second pick up, I can get bromine 81. This will make bromine 2 with a mass of 160. In my first pick, I may get bromine 81. In my second pick up, I may get bromine 79, which makes a mass of 160 again. Or I may get, in my first pick, bromine 81. In my second pick, I may get bromine 81 again. This will make a mass to charge ratio of 162. Probability of making this molecular ion then is a multiplication of these two numbers, 1 out of 2 times 1 out of 2, which makes 1 out of 4 would be this molecular ion. These two molecular ions are the same, and if I multiply the probability of first peak and second peak, then I will get a probability of this making these ions, which has both two of these ions the same. Then I will get a probability of 2 out of 4. I have to add up these probabilities together. Finally, making this molecular ion with a mass of 162 has a probability of 1 out of 2 times 1 out of 2, which makes 1 out of 4. Okay, that means if I analyze this ion, molecular ion, in a time of flight mass spectrometer, then I will get this mass, and this mass with a relative abundance of 1, with a relative abundance of 2, with a relative abundance of 1. I will see 3 peaks with the masses of 158, 160, 162, with the abundance of, as you can see, only 1 out of 4, 1 out of 4 would have a mass of 158. Just this is one. 2 out of 4 would have a mass of 160. 2 out of 4 would have a mass of 160. 1 out of 4 again would have a mass of 162. So if you know this probability diagram, if you can easily draw this probability diagram, then you understand why we get 3 peaks in a mass spectrum with the relative abundance of 1 to 1 ratio.